So, these, well, technically 4 triangles on the board. What type of triangles are they?
Right triangles.
Okay, good. They're right-angled triangles. And how do you know that they are right-angled triangles?
They have 90 degrees angle.
Yeah, good, because this symbol here means a right angle. It's 90 degrees, okay? So they've all got a 90 degrees in them. And actually, that's going to be the theme for the next, for the next lesson. This is, we're going to start a new thing called trigonometry and sectors. And this kind of feeds into it. It's literally the maths of right-angled triangles, okay? So these are all right-angled triangles. Now, how are we going to solve this first one?
Pythagorean theorem.
Good, so we're talking about Pythagoras.
Oh, Pythagoras.
Yeah, good. So this is the Pythagorean theorem, or Pythagoras' theorem. Now just remind me, if I just have any general right-angled triangle, so I'm just going to draw it like this, okay? And I'm going to make it general, so I'm just going to call the sides whatever I like. I'm just going to go A, B, and C. Now you notice that there's one side which is longer than the others, and it's always longer than the others. In this case, which is the longest side? It's C, okay? Now, does anybody know the special name for the longest side of a right-angled triangle?
Hypotenuse.
Yeah, good, it's the hypotenuse. Okay? Hypotenuse, right? So, in this case, what would Pythagoras' theorem be? Can anybody just recite it for me?
C squared equals A squared plus B squared.
Yeah, good. So you sum the squares of the 2 shorter sides, and that should be equal to the square of the longest side. Does that make sense to everyone? Yeah, has everybody seen that before? I don't have to revise that. Anybody not seen that before? Okay, good. So yeah, so it's just basically an application of this here. So let's have a look at this. I've got a 3, I've got a 4, and I've got an x. Now in this case, the x is the hypotenuse. Would you be happy with that? Okay. So if I just apply this theorem here, I would say, okay, that could be A, that could be B, and that could be C, which would then mean that 3 squared plus 4 squared must be equal to the hypotenuse squared, in this case, x squared. Does that make sense? Okay. Now what's 3 squared?
9.
What's 4 squared? Okay, so 9 plus 16 is equal to,
5.
so x squared is equal to 25. So what's x going to be equal to in this case? It is 5. Now, strictly speaking, I should write plus or minus 5, shouldn't I? If I didn't know about this, if I just gave you that equation there, x squared equals 25, you would hopefully tell me, there's 2 answers there. We've done that before. Yeah, we did that with quadratics. So it should be plus or minus 5. But why in this case is it only positive 5?
Because the length cannot be negative.
Exactly, because we're literally talking about a length here, it doesn't make sense to talk about negatives, yeah? Because lengths can only be positive. Like negative 5, what does that mean in terms of lengths? Does that make sense to everyone? So just bear in mind, it is still plus or minus 5 if you're looking from an algebraic point of view, but because you're applying it to a right-angled triangle, in other words, things with lengths in, you can only have positive 5. Okay? Good. Now actually, this type of triangle is a special type of right-angled triangle. Okay, because you've got 3, 4, and 5. In other words, all the side lengths are, what's the special word? Sorry?
Consecutive.
In this case, they're consecutive, so 3, 4, and 5. Yeah, that's true. But would you be happy that they are all whole numbers as well? Yeah? Now, in general, that's not always going to happen. That's not always going to happen. But when it does happen, does anybody know the name which we give to the set of these 3 numbers, set of these 3 sides? It's called a Pythagorean triple. Okay? So basically when you have 3 sides of a right-angled triangle, which are all integers, they're all whole numbers, we would call those 3 numbers, the set of those 3 numbers, a Pythagorean triple. Does that make sense? And the great thing about this is if we scale this triangle up, in other words, make it twice as big, because 3, 4, and 5 is a Pythagorean triple, so would 6, 8, and 10 be. Yeah? Check it. 6 squared is
36.
8 squared is
4,
equals
100.
10 squared. Does that make sense? And I could keep going. So 9, 12, and 15. 9 squared is
That's 81.
81. 12 squared is,
144.
121.
if you add them together, what do you get?
Oh, 130. I'm not sure.
That's 144, 12 squared.
144.
If you add together 81 plus 144, what do you get?
Also 7 to 11.
It should be 15 squared.
24 to 11.
Yeah, exactly. It should be 15 squared. Yeah, 225. Does that make sense to everyone? Yeah? So these kind of set of numbers are useful, and it's useful to try and recognise these. Yeah? Useful to recognise these. Okay, good. So how would you solve this one here then?
Same.
It's the same thing. So you've just got to be careful. Just identify the longest side. Identify your hypotenuse. So in this case, would you be happy the 13 is the hypotenuse, even though I've orientated it in a slightly different way? So I'm going to call that side C. How could I be sure that the longest side was 13?
Because it's facing the right angle.
Absolutely. It's got to be opposite the right angle. Does that make sense? Like over here, it's the side opposite facing the right angle. Okay. So if that's C, it doesn't matter what's A and B. I'm just going to go A and B there. And then I just apply Pythagoras' theorem to this. Now, actually, this is fairly straightforward. I just stick the numbers in the relevant place. Okay. So I've got A squared plus B squared equals C squared. So does anybody want to help me out?
13 squared minus 5 squared.
Okay, so you've jumped a couple of steps. So yeah, okay, good. So you've got x squared plus 5 squared, first of all, equals 13 squared. I'm just simply applying the formula, first of all. Yeah. Good, excellent. And then you've noticed, well, I want the x, so I'm going to chuck the 5 squared over that side. So x squared equals 13 squared minus 5 squared. So what's 13 squared?
169.
What is 5 squared?
25.
Okay, so what's 169 minus 25?
143. 144.
Good. So x squared equals 144. To get x, what would I have to do?
Square root.
Square root it. Strictly speaking, it should be positive or negative, but in this case, because it's a length, it's just positive. So what's x going to be equal to?
12.
Good. Well done. Make sense? No questions? Good. Excellent. A little bit more tricky. Does anybody get this one?
Yeah.
How do we do it?
We first use the Pythagorean theorem. We use the theorem for the first triangle from up, and then we use it on the triangle down.
Yeah, absolutely right. So you basically look at the top triangle and you apply Pythagoras to this one. So if I call that A, that B, that would have to be C. Okay. In other words, I would get 6 squared plus 4 squared is equal to C squared. So what would C be equal to in this case?
36 and 16. 36 and 16. 40, 52.
Good.
Square root of 52.
Good, exactly. So C would be equal to the square root of 52,
Which is the square root of 13.
which is 2 square root of 13. Absolutely right. Okay. Now you notice in this case, this wouldn't be a Pythagorean triple. Yeah, because they're not all integers. Like 2 root 13 is not a nice number. By the way, we've got another Pythagorean triple up here, didn't we? 5, 12, and 13. Yes, that's another Pythagorean triple. But yeah, this one isn't. Okay, so in general it isn't. So now we know that this side is 2 root 13. How could we use that to find x?
Like the second example.
Exactly. So that would be A, that would be B, that would still be C. Okay, that's fine. So we're going to get x squared plus 2 squared is equal to 2 root 13 squared. Okay, so you get x squared is equal to this thing, which is just going to be 52, because I noticed that's the square root of 52. If I square it, it's going to become 52. I'm going to take away 2 squared, which is 4. So I end up with x squared is equal to 48, which means that x has got to be equal to the square root of 48, which is 4 root 3. Okay. If
No, it's just square root of 58. There's no...
48.
Yeah, square root of 58. Oh,
48, yeah. So it's 4 root 3. Yeah. Now the thing is, if the question said, leave your answer in an exact form, okay, would you be happy that you just leave your answer like that? It's got to have the square roots in. We've talked about that before, the exact form. Yeah. If the question said leave your answer to 2 decimal places, what would that be? So what's 4 root 3 to 2 decimal places? 6.93. 6.93. Do you all agree?
Well, we can use the calculator for this, right?
We can use the calculator for all exams. Yes, absolutely. But I would always say, get in the habit of thinking it through for yourself. So actually, the only bit you need a calculator for was that last bit. Would you be happy? Like the rest is just surds. You can work with surds. Yeah? So get in the habit of trying to do it yourself, because if you rely on a calculator all the time, you've got no idea whether it's right or wrong. Whereas if you get in the habit of going through things yourself and working through things yourself, you can usually sense, hang on a minute, that doesn't make sense. Okay? Train your mathematical senses.